or don't know how to. All right, so this is the iExperts webinar. My name is Grant Fritchey, and this is learning Postgres as a SQL Server user, but also it's really just learning Postgres. We're going to talk about PostgreSQL. All right, let me get slides. There we go. So my name is Grant Fritchey. I work for Redgate Software. Yes, that's an old picture. I'm going to get a newer one updated soon. But anyway, I'm a Microsoft PostgreSQL MVP. I think there's like 2 of us on the planet. Also, I'm also an AWS community builder. I work for Redgate Software, and this is my contact information. If you want to get in touch with me after today, please use it. There's my email, LinkedIn. My blog is probably dead, but it's going. Anyway, feel free to reach out and get in touch with me. I will answer my emails. So you've got it. Please use it. All right. What we're going to talk about today is first, why Postgres? What the heck's going on with that? We're going to talk about the language of Postgres, not so much the programming language, although we will cover that, but more just terminology that's important for you to have when we start talking about Postgres. We're going to talk about the things that are the same, things that are different, things that are just weird, and then where to go and get more information and learn more about Postgres, because I'm not going to cover everything today. Just couldn't possibly. It's a gigantic topic. Cool. All right, so why Postgres? Well, before I answer that question, I want to give you one bit of information that you need. How do you say it? PostgreSQL is the full pronunciation, PostgreSQL. So it's PostgreSQL. All right. That's it. I just wanted you to have that because that way you will sound better instead of saying PostgreSQL, all the other variations you hear. It is PostgreSQL, and if you've got that much, you're already going to sound smarter. Or you can cheat, and Postgres is fine. All right. So why Postgres? What's going on with Postgres? Well, it's the good aspect of it is it has an extremely permissive open source license that is fantastic. The core features cannot be paywalled. Therefore, the core features are just going to forever be available to everyone. And most of the extensions that are available for Postgres and the extensions are the magic. And we're going to talk about that today. The extensions are the technical magic. Why would you do Postgres from a technical standpoint? It's those extensions. But the real issue is the licensing. That's the thing that drives a lot of business makers to go after it. Because why? It's free. Now, that's not a true statement. There is no such thing as free. There's a payment somewhere, somehow, something. Now, Postgres is license free. And therefore, from that standpoint, you can get into it and use it. But the fact is the majority of people are using Postgres on the cloud. And the majority of those people using it on the cloud are using it in platform as a service offerings. Therefore, it ain't free. You're actually paying money for it. So don't get hung up on this free thing. It is the worst reason to go to Postgres. I love the licensing. It does make for a very vibrant community that's doing amazing work. 100% behind them. I hope to become a contributor at some point. I'm still a little ways away from that, but that's my plan. Regardless, the OSS thing is the open source software thing is a huge and important reason to go. But the real reason to go is the extensibility. The language support, obviously SQL, SQL, C, Rust, excellent, but there's other languages in there too, Python, a whole bunch of others, and more than 30 different hooks available for extensions. And the extensibility is why Postgres. You want to understand why this is taking over the world, why so many people are going for it. It is these extensions. The core engine is good and getting better all the time. But it's not a game changer. The core engine would not by itself drive me to move to Postgres. But when we start talking about extensions, that is why I would go to Postgres. That is why I have migrated into Postgres. I have not replaced my SQL Server. I'm still firmly entrenched there, but I have added the Postgres skill set because of these extensions. It is a huge reason. The whole thing is that it's not just about extending the functionality. It's not just about adding, a new backup methodology or a new way to store GIS data or time series data. And all of these are some really cool reasons to use it. But you can actually use this extensibility for your own functionality within your own business, within your own organization. And versioning this extensibility, you can grow your code for your own stuff. And if you've got multiple databases, multiple clusters, you can use the extension packages as a way to install functionality onto your servers. So this is a great set of tooling for more than just changing the functionality. All right, I'm keeping an eye on the chat, so if any questions come up, I will try to jump on them as we go along, so don't hesitate to use it. Otherwise, I'm going to keep rolling. The language is really important because the same words don't have the same meaning, and that is the Tower of Babel for those who don't know, and it's an old story about language and the loss of language. It's really important that you learn the new terms. Postgres uses some terms differently than other data platforms. It uses the terms the same as other data platforms. But if you learn the language of Postgres, you will then be able to communicate with Postgres people easier, and the Postgres people will be able to communicate with you easier. And you won't be, I have a story I'll share in a minute, but you won't be in my situation where you pound your head against a wall because of the language difference. And so that's why I really focus first on the language and on terminology, because it makes a difference in the way we talk about the tool. And getting that language right is an improvement on communication. So that's where I want to start with is the language. All right. So we did say SQL Server was going to be our baseline, and we'll talk about how to move to Postgres. But still, this is very much about learning Postgres, not so much moving from SQL Server to Postgres. In SQL Server, we say instance. In Postgres, we say cluster. They mean the same thing. However, there's also a term called cluster in Postgres that means the same thing as a cluster in SQL Server. So it's a collection of clusters in Postgres. It would be a collection of instances in SQL Server. So anyway, instance means cluster. All right. User means role. Now, again, in Postgres, there are users, but the primary mechanism for controlling security is the role, not the user. So you want to make sure that you're taking advantage of that language and using that. Next up, the transaction log is also a log. It's just the write-ahead log or the wall. It's frequently called the wall. You hear wall a lot. You'll see WAL written a lot. It's the write-ahead log. And it serves mostly almost identically the same functionality. It is a recording of the transactions occurring on your database, meaning you insert a row, that insert statement gets recorded into the wall, and you can replay the wall as part of replication or as part of data recovery. And there's all kinds of, same idea as it is in SQL Server. It's a protection for transactions, and it's a recording of the transactions as they occur. Inserts, deletes, all that fun stuff. Okay. Row, they do call it row in Postgres, but they also frequently refer to it as tuple or tuple. I'm not going to get into that fight. If you prefer tuple, good for you. If you prefer tuple, good for you. Regardless, you will see the phrase tuple a lot. Just know it means row. That's it. You will also see row in the same place. And so that's fine too. But rows are tuples in Postgres. All right. This one stuck with me. It took me 3 days. When I was first learning Postgres, I was 3 days trying to create a procedure to return data. Procedures in Postgres don't return data. functions in Postgres return data, similar to Oracle. Oracle's got the same terminology. A function in Oracle returns data, not a procedure. However, SQL Server, it's a procedure that returns data. I spent 3 days trying to get a procedure to return data, and they won't do it. They can return individual values, but they cannot return a result set. And that's because what I think of as a function in SQL Server is a procedure in Postgres. So we'll cover this in a little more detail, but I just want to get that language down. I've just saved you 3 days. You're now able to ignore the procedures, go straight to the functions, and you'll be a happy camper. All right. That's about it from the language. We're going to get into a whole bunch more details and stuff, but I want to make sure I covered that right up front. Just checking the chat. Okay, cool. And we're doing good on time. So off we go. So what's the same? What's similar in Postgres? What are the anticipated behavioral stuff? Well, Postgres is a relational data management system. It uses SQL, structured query language. It uses normalization. All of these things that you already know if you're already working inside of any of the relational data platforms, MySQL, Oracle, Sybase, Access, for crying out loud. All of them are the same. Now, the one key difference is Postgres is built as an object relational database management system, which does introduce some differences that we'll cover in a little bit. But by and large, it is exactly what you think. The core concept of this data platform is exactly the same as the core concept of other relational engines. So structured query language, SQL, SQL, is definitely going to be part of it. Normalization of your data is definitely going to be a part of it. And so just know that that information that you already have, that knowledge you already have, transfers straight across. And that's the important part. All right, so common across both. Database is a database. Schemas, tables, primary keys, foreign keys. These things all mean the same thing in Postgres as they do in SQL Server. There's no shocks, no surprises. Table is for structuring data. Primary key is for identifying an individual tuple or row. A foreign key is, making those connections between tables. All of these things are very, very common. All of these things behave the way you would expect. Now, are there detailed differences? Of course there are. There are lots of differences, but the broad scope, a schema is an organizational structure for storing the data within a database, same in Postgres as it is SQL Server. Can you set security to a schema in Postgres the way you would in SQL Server? Yes, right? So it's very similar behaviors. So that's why I say it's common. Are the details different? Yes, but the behavioral concepts are the same. When we talk about them, a column in Postgres is what a column is in SQL Server or DB2 or Access. It's very common across all of them. A view is a view. Yes, there's such a thing as a materialized view, and there's also detailed differences, but the core concept is a view is a query that behaves similar to a table. Yep, same idea. Indexes. Now, there are gigantic differences in the indexes in Postgres, but the core concept of an index is exactly the same. Hey, this object will help me find data. Cool. That's what we need. Triggers, same idea, right? I've made a change. I've done an insert, fire a trigger. What we here mean by object relational. I'm going to dig into that a little bit more in a little bit, I promise. I'm just glancing over for questions. Constraints. Now they've got some really cool constraints in Postgres. So there's, again, detailed differences, but the commonality is the same. Data types are a type of constraint. Only text fields, right? Only number columns. That's all very similar. But also you can say only numbers below 10, right, as a constraint. Stuff like that. All the same. So those concepts are the same across them. So you won't have to worry about those. A query is a query is a query, right? I mean, it's you're inserting data, you're updating data, you're selecting data. Yes, they are the same concepts. So I wouldn't sweat those. There are tons and tons again of detailed differences. Now, the select statement, it's select, define some columns, from, define the tables, uh, on, join on, right? All of those key concepts and key words are the same. Where, some value equals some value. Again, all the same, but the details are what's different. In fact, Postgres, by and large, is probably the most ANSI compliant set of queries that you will see anywhere. Now, they do deviate from the ANSI standard. Either they were ahead of the ANSI standard or they're doing stuff different from the ANSI standard because of, reasons within Postgres, which will make sense logically. But by and large, they pride themselves on ensuring that the ANSI standard is followed. So you will see a lot better ANSI standard compliance within Postgres on the queries. Okay, so that's the commonalities, and again, broad stroke commonalities. There's again, I can't emphasize enough. There are very significant detailed differences, but broad strokes, those things are the same. All right, so what's different? What's in some cases very different? All right, case rules. In Postgres, everything's lowercase, unless you double quote. If you use double quote, you can then have upper and lowercase object names. I wouldn't. I would strongly advocate against it. The standard in Postgres is to use snake case, right? Underscores between the words to make it easier to read, right? To make it more clear. And remember, language object names are communication, and communication, especially within IT, needs to be as clear as humanly possible. The more clear you can make your object names, the better it's going to be for you in the long run, because 2 weeks, 2 months, 2 years from now, you're wondering, what the heck is that object doing? Why is that there? If it has a good, clear name, you'll know. And if it has some really obscure index number 42 name, uh, who knows why it's there. But all the object names are lowercase, and it is extremely common to see snake case. I tend to follow that now when I'm working in Postgres. But that's one thing that is very different, especially for those of us who are very comfortable in SQL Server and having that snake case as part of our standard. You'll have to let that go unless you want to use the quotes, and I don't recommend using the quotes. So there you go. All right, SQL. There's a whole ton of differences. I like the first one. I always put it in because I wrote a book with Ryan Booz, great guy, by the way, Ryan Booz. If you're looking for a resource and somebody to follow, I would follow Ryan. Actually, I do tend to follow Ryan. But Ryan and I wrote a book. I was working on the book, and I wrote. I was working actually on the chapter on SQL, on SQL, and I wrote a query. I wanted to make a change to the query, and instead of making the change in my source code, I made the change directly in the text, sent it off to our tech editor. Well, I wasn't thinking, and I wrote top, and my tech editor simply wrote back top with a question mark on the tech edit. And so, yeah, sure enough, I missed it. It's supposed to be limit. It's limit instead of top. Now, another difference you'll see a lot in Postgres is you will see ordinals used instead of names. Can you do this in SQL Server? Yes, but it's never been the standard approach. We've never said order by number 13, right? We've always said order by a column name. Postgres, the standard has long been to order by an ordinal instead of by the name, and in other places where ordinals can be used. I'm appalled by this, not because it's wrong or bad. It's not. It's fine. It's not clear communication. What the heck is column number 13? Well, now I've got to go and count. and I don't want to count. I just want to know which column it is. Oh, someone says they're currently reading the book. Well, thank you. Let me know if it's not useful, and if you have questions, please ask. So I'm not crazy about this ordinal thing, but you will see it. It's a very standard practice within Postgres, and so I'm bringing it up to you so you know. They use a single date part function instead of lots and lots of specific functions, which is really cool. I love it actually. I'm very much in love with it because like I've got a single place to go, and I just got to read the documentation to figure out what I need to do instead of breaking apart. And then they use lateral instead of cross apply. And there's actually a very firm push in Postgres to not use lateral at all. But even as there's places where cross apply works better, there are places within Postgres where lateral works better. So I would still use it in the places where you use cross apply, but I would test it carefully. And I bring these four out just because one, the limit instead of top got me. So I figured I would share it with you. And the others are things that you're probably going to hit fast. And so I wanted to bring those up right away. The ordinals instead of names, don't do it. Use names. You can. Postgres fully supports it. Names are clear. Ordinals aren't. But when you're looking at documentation written by others, you will see those ordinals. So be prepared for that. Okay. Now, in SQL Server, we have a thing called model DB, which was a template. It was, when you create a new database, it copies the model database as the basis. Well, Postgres has these two, and it's called template 0 and template 1. It has two of them. And you can create your own. So you can create your own database templates and then create databases from those templates. You can even create a database from another database. You don't even have to use templates. I would tend to use templates. Matter of fact, I would advocate for using templates. It makes things more clear. You get more standard behaviors. But the thing about the templates that you need to understand is that there are two built into Postgres core, comes that way out of the box, template 0 and template 1. Leave template 0 alone. Don't touch template 0. There are a whole slew of extensions that assume that template 0 will A, be there, and B, not have anything new, different, or strange in it. It will be exactly what it's expected to be. And if those extensions don't see a template 0, or if there is stuff inside of template 0, it could cause those extensions to, die. So leave template 0 alone. That's not yours. That's a core thing for the behavior of the system. Template 1 is yours. If you want to add stuff to it, like, we used to be able to add stuff to model DB, you can add stuff to template 1 or create your own custom template. Either way, that's the best approach, is to follow that template 1 is customizable, template 0 is sacrosanct. Don't touch template 0. Everybody cool with that one? Okay, I don't see any questions. Create database. Now it defaults to template 1, but you can pick the template and you can define the owner. I strongly recommend you get in the habit of defining the owner. Define a role that's going to be the owner of the database. Don't let it be the default. Don't let it be, the super user in the system. Make sure you define the owner. It's a good habit from a structural standpoint. It's a good habit from a security standpoint, and it gives you more direct control over the behavior of that database if you define an owner right up front. That's it's a good practice to get involved with Postgres. Sure, in SQL Server, DBO is always DBO, right? Database owner. But Postgres, it's different. You get to pick the owner and you can define it. Can it be the super user? Sure. Most of my demo code is, but I would not do it with my production data that way, just so you know. All right, backups and restores. All right, this is a huge, huge topic, and we're not going to be able to cover all of it. The core behaviors inside of Postgres itself are technically not backups and restores. They are technically just a methodology of doing a dump. In fact, PG dump, PG dump all are ways of doing a database export, a dump. They are not backups. Now there is PG-based backup that is also incremental now, which, yay, incremental backups, is a backup, but it is a backup of the entire cluster, all databases on the cluster. Now we'll get into backups in more detail. We're going to cover it in more detail, so don't start piling me with backup questions. I'm going to try to answer a bunch of those as we go. But PG Restore works with PG-based backup. The real key for backups is extensions. If you've been following the news, there's the big extension is PG Backrest, and it's right as I talk today, it's out of support. It's going to get supported. Someone's going to pick it up. I guarantee it's going to get forked and everything's going to be okay. But today it's out of support. If you're really freaked by that, there's also Barman, which is another way to do it, another extension for doing backups. I would strongly recommend you don't rely on the core for your backups, that you use one of the backup extensions. And the one I would lean on is PG Backrest, but just know right now, today, that's not supported. It happens with open source software. Anyway, this is a big difference in the way backups work. You need to know this and get in front of it. We'll get some more detail on backups here in a minute. Data types. I tried counting and I never got the same number twice. And also they're constantly updating and putting new stuff in Postgres. It moves so quickly. It's wonderful, but it's also a pain. I only got about 125 data types. I was able to get the accurate count on the categories. So there were 20 categories. So yes, there's a lot of different data types here. Stuff that you would expect to see, varchar, car, int, float, right? All normal behavioral stuff you would expect to see it, but then a whole bunch more. And that's before we start talking about extensions, because the extensions can add data types. So there's a great deal of information here. Most of it's cool and wonderful and useful. Some of it's garbage, and you'll figure it out as you go along. The bits and pieces that are garbage are tiny, so I wouldn't sweat them. Data type behaviors, just a few things. Fixed or variable length is exactly what you would expect to see. Varchar 50 is going to, be limited to 50 characters. Text is going to, not be limited to 50 characters. It's not going to be limited. One thing you will see a lot from Postgres people is it is very much a developer's database written by developers for developers. And so they tend to create tables with text instead of Varchar 50. Why? Well, what happens when we need to go to Varchar 75 2 years from now, 3 years from now, 5 years from now? We'll have to change the data type on that column, and that'll be a pain. So we'll just make everything text, and we'll worry about it from the code side, from limits. I'm not a fan. I won't lie. I prefer putting limits inside the database design, but you will see that. So I figured I'd bring it up. Data types can be null. You can define default values. And the one thing to know about the data types is that they are objects. And the question was, what do I mean by an object relational database? Everything in the database is an object. So that means that you could create a data type that is a nested data type. So you could create a varchar inside of a varchar. Yes, you can. You could create an int inside of that varchar. You can nest these things. How deep can you nest them? Far too deep. You can do heinous things to your database. Don't do this, but you can, because everything within this relational database engine is an object and can be treated as an object, and therefore you can start doing things like nesting data types. Don't. Protect yourself. Love yourself. Don't do that. You can, but you shouldn't. All right, indexes. All Postgres tables are heaps. Now, every person who knows SQL Server just gasped and fell over in a faint, but it's okay. Don't worry. It's just the way Postgres works. It doesn't have the concept of clustered storage. Everything is simply stored as a heap. It's okay. It's okay. It's just how it works. So don't sweat it. For those of you who don't know what clustered indexes are, don't worry about that either, because if you're going into Postgres, you don't need to know. So it's all good. One of the things you should know about Postgres is because of the way it works, and we're going to get to how it works. Um, you can create and drop indexes concurrently. So you can create a new index and drop the existing index at the same time. I I love it. You do have to be the owner of the table to add indexes to it. And I just point that out because ownership becomes a deal within Postgres way more than it does in SQL Server. So it's just worth bringing up. All right, index types. They've got a whole bunch of index types plus extensions. Most of them are going to be stuff you would expect to see. The B tree, balance tree, or it's actually a B plus tree, same as it is in SQL Server. Balance tree indexes are exactly what you would expect. A page with pointers down to other pages with pointers down to other pages where the data is stored. It has a hash index, which is wonderful. I love hash indexes. It's for near identical data. It's not exactly identical, but it's close to identical. So you do a hash on the key column, and then use create hash buckets and store the data within the hash buckets. And that's a great way to go for near near identical data. They've also got the generalized index, the gist, the partition generalized index, the SPGIST, gen, brin, binary range index, and the gen index, which are gen index is good for reverse data lookups. So it's actually a great way to go. Brin is more for ordered data, like data types or the date data types, stuff like that. But these different index types are fantastic. And then there are extensions using these data types to create new data indexes. We're going to cover extensions in just a little bit. Core procedural language, it's SQL. Specifically, there's procedural language, PL, and that is PL, PG, SQL. That's what you're going to see the most. But you can do PL Python, PL TCL, PL Perl, and there's actually several others. They're not generally supported real well, but these are the big ones. But by procedural language, I mean like when you need to do a case statement, that's not part of SQL. It's not part of the SQL language. That's a procedural statement. And so those procedural statements require a different language, and that's what's going on here. Let's see. Server metrics. All right, this is where things get a little bad. We have the error logs, and that's where a lot of people do their data metric collection is by injecting metrics into the error log. I find it a little bit problematic coming from a place where we have a very extensive, very extensive instrumentation to Postgres where the instrumentation is just reduced. But it's okay. You can get by, you can get most of what you need, maybe not everything, but you still can get it. The one thing they do have is the cumulative statistics system, which is great. I really do like it. Think like the DMVs inside of SQL Server. It's a way to query information about what's going on. The CSS is off by default. The people who built Postgres are one, they're really nice people, really kind, very giving. I really love the Postgres community, but they're also smart. And one of the things that they did intentionally was, hey, we're going to set up the core behavior of the engine so we do as little harm as possible. And so therefore, cumulative statistics system, yeah, probably most everyone's going to turn it on. But just in case there are people who don't need it, don't want it, we're going to leave it off by default. Cool. It's off by default. You just have to turn it on. But once you turn it on, it's easy enough to do. It does reset on crash or failover. It does reset on a point in time restore, and you can manually reset it. And the one thing to know about it is it's aggregates only. It's very similar to the way the DMVs work. So what's in it? Well, current activity. What queries are running? What's going on your, what queries are running inside the database? What is currently happening? Cool. Good, useful stuff. Information about the database. How many rows are moving in and out of the database? How many connections? All that fun stuff. Tables. They break it down. Tables, indexes, and the I/O on tables and indexes. They break it all down by all, meaning every table, sys, meaning just the system tables, or user, meaning just your tables. I use pgstat user tables all the time to get information about what's going on inside of a table, or pgstat user indexes to see what's going on inside of an index. So those are fantastic resources, and I love that it filters for you by the user. So it makes it a great way to go. You also get specific info on blocks and storage, the way it's written out to pages, and a lot of the internals are fairly similar and not surprising. All right, query metrics. Now, query metrics, we've only got a couple of things. We get explain, analyze, and we get pgstat statements. Now, pgstat statements, again, disabled by default, right? Do no harm by default. Cool. You want to turn it on, and most people do. Awesome, you can. You can also capture statements, query statements, into the logs, and a lot of people do it that way, and you can get more detail in the logs than you can with pgstat statements. Pgstat statements is aggregates, so you won't see detailed calls. You will only see aggregate calls on a given query. All right, let me just check for questions on what we've got so far. All right, what's confusing? All right, all of that stuff was different, but not crazy. Let's get into crazy. All right, restore to a point in time. I'm not going to read through all this, but if you're using the core product, this is how you do a restore to a point in time for all the databases on your entire cluster. And no, you can't do an individual database unless you use an extension. I'm not going to cover all these details. You can read through it, but look through those steps and tell me that this was not written by a developer with very little experience doing administration work, because boy, it sure looks like it. I love them. I love them. These guys are amazingly smart, but experience can teach you things that big brains and knowledge doesn't. Anyway, you see it. There you go. Functions. Functions are implemented to return data. It's very similar to Oracle or SQL Server procedures. You select from a function, which means you can join functions to each other. And yes, that has serious performance implications. You are going to want to test that, validate that behavior. Again, these are all objects, right? Going back to that question, what is meant by object relational? These functions are objects, and therefore they're treated as such. So you select from a function. Procedures, again, perform actions. I generally have been using procedures for doing inserts, updates, deletes, because it passes in the values and it gets the thing done, and off you go. Functions are for returning data. Procedures are called. So you call a procedure. Can't do it through a query. You have to do it through a call. And you'll notice that do loop, do, $, that is PL PGSQL at work. I'll cover that in just a little more detail in a minute, but that is a procedural language doing some of the heavy lifting here to allow me to declare variables and then run queries, call my procedure in this case. All right, the MVCC. This is a big one, the multi-value concurrency control. By default, out of the gate, readers don't block writers, writers don't block readers, is the whole idea behind this. And it's, if you're a SQL Server person, I would compare it to read committed snapshot isolation. Similar concept. It's not the same. It is very, very different, but the concept is the same. The whole idea here is that when you do an update in Postgres, it is an insert and a logical delete. It is not an in-place update. Now, Postgres deals with this extremely well. It is a fundamental behavior of the system. It's core to how it behaves. But you need to know that because you can't assume that what it's doing is making changes to an existing page. It is literally marking that page as deleted and inserting a new page. That has implications. The implications are bloating. You're going to see lots and lots of dead tuples, right? Tuples that have been, quote unquote, deleted, but they are still in the system. There's a process called the vacuum that comes along and takes care of that, removing the old rows. Now, you're going to spend a lot of time in this. This is one of the, remember TempDB and how painful managing TempDB is inside of Postgres? I'm sorry, inside of SQL Server. Well, A, there's no TempDB in Postgres, but B, from a oh my God, I've got to spend time dealing with this situation. The MVCC is very similar to TempDB. They are not the same conceptually. Don't conflate the two. I'm just using it as a comparison point for the labor involved in managing it. Okay, the labor involved in managing the MVCC is the same as the labor involved in managing TempDB. All right, the vacuum. This is our baby. However fast you're running it, however frequently you're running it, you're probably not running it often enough. So that's one of the things you will be looking at. It cleans out the dead tuples. That reduces our overall bloat, keeps our databases smaller, and it updates statistics, which behave very similarly in Postgres to how they do in SQL Server. It's data about data and gives the optimizer information, so it makes good choices when it creates execution plans, also called explain plans in Postgres. But this is really important. We need to run the vacuum to clean out the dead tuples. We need to reset the transaction IDs, and we need to update statistics. Vacuum is our magic process that takes care of all of that. That is the one thing that you really are going to want to keep an eye on. Make sure you're running it as frequently as you can. You may need to, you can run, there's a vacuum all, and it vacuums the whole database, but you can also vacuum individual indexes, individual tables. You may need to do that as you go. You will figure it out, but you may need to take very direct control over the vacuum, depending on your situation. But again, probably you need to run it more frequently than you're running it. All right. How do we get started? How do we start learning Postgres? Well, it's supported everywhere, right? You can run it on Linux. I've got it running on a Raspberry Pi back behind me here. You can run it on Linux. You can run it on Windows. You can run it inside of containers. You can run it on the cloud. So anywhere you want, you can run it. There is what is called the core. The core is for the hackers. Now, who are the hackers? Hackers, that's bad. No. Hackers are the people who build. They are the individual contributors who build Postgres. They're the ones doing the hard work. I love the hackers. You should love the hackers. They are good people. But the core is for them. What you're going to look for is packages. The packages are specific to your operating system, or they may have special functions. Like one package I'm running recently is timescale for time series data. I'll get to that in a minute. The easiest way to get started, I think, is containers. You don't have to install anything. You spin up a container, off you go. You can do work from it. There's all kinds of forks available on it. Just make sure you get in the habit of creating volumes because it makes it easier to back up your data and move your databases around. Cloud, all of the major cloud support vendors support Postgres. They're all using it, whether they're using it, as close to the core product as they can, or they've forked it and created their own thing. Azure has forked it. Google has forked it. AWS has forked it. Enterprise DB has forked it. Everybody's forked it to make changes to what they want. But they also have all of them have a very close to core behavior. All right, tooling. Probably just about everywhere there's a command line tool called PSQL. Right, PSQL is available. It works remote. You can connect up to the cloud with PSQL, no problem. It's like SQL command, right? Same idea. And this is a very great tool to learn from an automation standpoint. I know some people who will only ever use this to do all of their work. I am not one of those people. So there are GUIs. pgadmin is the official, unofficial, or the unofficial official PostgreSQL GUI. It's not installed by default. I can't even be nice. I hate it. I'm not a fan. I don't like it. But the people who built it love it, and some other people who didn't build it love it as well. It is web version, so you can do remote work with it, and it comes with its own extensions, and so you can extend the functionality of pgadmin, which is really cool. It's a nice tool. I'm just not a fan. What I am a fan of is VS Code. VS Code has some fantastic Postgres extensions. It's really good for basics. Some of the more advanced features in Postgres aren't supported well within VS Code, even with the extensions. But most everything you want to do, query writing, development, management, all of it, backups, whatever, you can do it through Visual Studio Code or VS Code. And VS Code has great integration with source control and I'm a source control advocate. So anyway, the one I use the most though is dbeaver. Now dbeaver's got a couple of issues with it. Overall, fantastic tool, amazing, wonderful tool, but it is multi-platform. And by that, I mean not, oh, it runs on Linux, it runs on Windows, although it runs on Linux and it runs on Windows. I mean that it supports SQL Server, DB2, Sybase, Oracle, SQL Server, and Postgres, and I think a few others. And because of that, it's that whole, jack of all trades, master of none kind of thing. It has some shortcomings in some of its behaviors. Regardless, I love it. There's an open source community version and there's also a paid version. And it has extensions. It also has code completion, which is pretty good. It's not great. I know a code completion vendor who could do a better job if we would ever do it. Won't mention that right now, but you get the idea. All right, how are we doing on time? Keeping an eye on it. Cool. All right, more learning. Well, there's the Postgres documentation. Now, the Postgres documentation is incredible. It is the most thorough documentation I have ever seen in my life. It is incredible, just incredible. But there are a couple issues with it. A, it is extremely thorough and academic and doesn't offer much in the way of guidance. It will tell you everything you need to know, but it won't tell you, hey, you don't need to know this, or maybe you shouldn't be using this function, you should be using a different one. It doesn't get any of that. It just tells you everything, and then it's on you to figure out which is applicable and which isn't. That lack of guidance is my only real complaint with the Postgres documentation, because it is the most thorough documentation I've ever seen. And I'm old. I've seen a lot of documentation. It's amazing. So you're going to use it. Just know going in that you won't get a lot of guidance from it. The other thing you need to pay attention to is I've got it highlighted there in a box, in a red box, for those who aren't colorblind, but it's a box around the word current. The reason I want to point that out is because when you do a search through, Bingle, whatever search engine you use, it will point you to the current documentation. It's something that they've worked out with the search engines so that it always goes to current. But when you go to somebody's blog, it's going to link to version 14 or version 15 or version 16, 17, 18 of the Postgres documentation. Well, cool, it linked to version 14. Well, there's been changes since version 14 and you're running on version 18. And the code that you're looking at now is the documentation for 14, and it doesn't work. And ask me how many times I've run into this. A lot. So I've gotten in the habit of checking the URL that I'm following to make sure it says current, and if it doesn't say current, what version it does say, and and if it's on the wrong version, I'm going to change it to the right version. Little trick. Now you have it. Now you don't have to go the hard learning curve I went through. All right, books. Yeah, Introduction to Postgres by Ryan Buzemi. I definitely recommend that. But honestly, The Art of Postgres by Dimitri Fontaine is probably still the fantastic book on Postgres. Another book I recommend is Database Administration. It's got nothing to do with Postgres. It's Craig Mullen's book about the job of being a DBA. And anyone out there who's, your job title is data engineer, but you're responsible for backups and high availability and performance, you're kind of doing the DBA job. You might want to read this book. And then Henrietta Dombrovskaya, I said it right. She's written a fantastic book on Postgres query optimization. So I pull all these out just because these are where I go to learn. So figure I'd share with that. And then online. Planet Postgres is a blog aggregator of Postgres. So I would jump on that one. There is a Postgres Slack channel, and it's pretty active. A lot of stuff going on there. Cooper Press maintains an email list. There's actually PG Help on X, and then usual AI. Again, AI. Remember, check the versions that it's linking to because it could give you bad information. But still, the large language models are a great way to go to learn Postgres. All right, now with that, I've got 8 minutes left, and I wanted to make sure I save some time for questions. So, oh, this version didn't have a section on extensions. Let me run backwards for a second and talk about extensions real quick. Some of the extensions you're going to want to look for are PG Backrest Barman for backups. You will definitely want to check those out. But also, you're going to want to look extensions, again, depending on your needs. And this is where it's cool. If you don't need an extension, don't get it. But let's say you're doing GIS information, global information systems. PostGIS is insane. It is an extension for GIS data, and it is amazing. It has GIS indexing that is fantastic. It has data types, it has functions, and all of these things are far superior to anything in SQL Server. If you're doing GIS information, you really need to look this up. Another extension you're going to want to be interested in is timescale. Timescale is for time series data. So if you've got a lot of data that's just very time series focused, meaning, this event happened at 522, and this event happened at 523, and this event happened at 524. If you're looking at that kind of data types, or that kind of data, you want to look at timescale because it changes the fundamental storage engine to optimize around time series. And it's blazingly fast. It collects the data faster, it returns the data faster, and it's got some functionality built into it that changes the behaviors of time series data in a way that just is head and shoulders again above anything possible within SQL Server. So that's some of the extension stuff that I accidentally left out, and now I've made sure I brought it back. With that, now we have 5 minutes left. So, all right, here we go. Would you recommend any book or resource we've found for query performance tuning? Yeah, again, Henrietta's book, fantastic resource. And she just released a new version. I've got the older version. I need to get the newer version. But it's a fantastic resource. So yes, that's what I would recommend. Here, I'll go back to it even. Give me a second. There. Postgres query optimization. It's fantastic. By the way, query optimization is not the main driver in Postgres. A lot of times, all they're doing is what they call server tuning, and they're making changes to all the knobs on the server, and there are a lot more knobs on the server to change the behaviors of the server itself to get better performance. Or I said server, cluster. All right, where are the clear advantages of Postgres compared to SQL, system-wise, business-wise, development-wise? Okay. Let me give you a positives. I'm going to give you negatives and then the positives. The negatives. Postgres Postgres itself is just not as good at high availability and disaster recovery. It's just not. Now, most of you are going to be running on the cloud. Most of you are going to be running on platform as a service offerings. That goes away. If you're running in AWS Aurora, for example, it has got amazing high availability and disaster recovery. Insanely great. But core Postgres, especially if you're running it on-prem, it's weak. Also, instrumentation. There's no such thing as extended events. There's no such thing as trace. There's no way other than debugger, and no, don't run the debugger on your production system. It would be bad. There's no way other than debugger to get instrumentation out of Postgres other than what's offered through the CSS and SP statements and stuff like that. So that's one thing. The other, so those are the negatives. The positives, extensions. I already mentioned time series data, time scale. I already mentioned PostGIS. There's a whole slew more. Those behaviors are head, shoulders, amazingly better than anything in SQL Server. And there's going to be more, right? Because there's a million people who need some specialty that they're going to develop in Postgres. No such thing as service broker in Postgres. No. Do they have something similar to merge replication? Yes, there is something similar to merge replication. I'm not a fan. However, again, if you're on Azure, they've got stuff that's better. If you're on AWS Aurora, I go back to AWS Aurora a lot. They're really good. Although if you're looking for performance, AlloyDB on Google. Oh my gosh, AlloyDB on Google, amazing from performance standpoint. You will pay for it, but it's great. Copy the slides. The slides are available on GitHub, ScaryDBA. I've got the slides posted already, so you can get them. And the recording will be sent out according to Noran Ali here. And all right, I think we've got like about a minute left. Any questions I haven't answered, or any questions you haven't asked? Well, okay, cool. The one thing I will say is grab a container, dig in, play with it. Postgres is amazing. It truly is. Oh, and I will say one other thing. One more thing. I've got a minute, right? You can run it on Windows. Don't. Sure, on a container, you're running on Windows and learning it. Cool, that's fine. But I'm talking about like production servers. You can run it on Windows. Just don't. Plan that you're going to be running it on Linux if you're going to run it locally. There's a whole bunch of details as to why. Just assume I'm going to Postgres, I'm going to Linux. Don't run it on Windows. You can, but you shouldn't. All right, I'll shut up now. Other than that, recovery model, it's a different animal. We'd have to a lot more detail. I'm not going to be able to cover that right now. Assume similar to read committed snapshot. Okay. With that, I think we're all done. I'm going to stop the share, and I'll rely on Neuron to control the recording. Thank you very much for coming, though. Thank you so much. Oh, well, thank you. And I'm not leaving